everyone. Today we are going to start a new lesson in Science and Technology Part 1. The name of the lesson is Refraction of Light. The subtopic that we are going to cover in this lesson are refraction of light, laws of refraction, refractive index, and dispersion of light. Let's recall. What can happen when a beam of light is incident on the surface of a transparent object? Consider a glass slab and suppose the narrow beam of light is incident on one side. The beam of light partially refracts, it reflects, and it is even partially absorbed by this object. You have studied reflection of light and laws of reflection in previous class. Do you remember those laws? Let's recall. First, we'll define reflection of light. When light rays falls on an object, their direction changes and they turn back. This is called as the reflection of light. Laws of reflection. There are three laws of reflection. These are as given below. The angle of reflection is equal to the angle of incidence. The incident ray, the reflected ray, and the normal lie in the same plane. The incident ray and the reflected ray are on the opposite side of the normal. Let us study one activity from the textbook. Take a transparent glass and fill it with water. Dip some portion of pencil vertically in water and observe the thickness of the portion of the pencil in water. Now, keep the pencil inclined to the water surface and observe its thickness. In both the cases, the portion of the pencil inside the water appears to be thicker than the portion of the pencil above the water. In the second case, pencil appears to be broken near the surface of water. Let us study one more activity from the textbook and then come to a conclusion. Keep a 5 rupee coin in a metallic vessel. Slowly go away from the vessel. Stop at a place when the coin disappears. Keep looking in the direction of the coin. Ask a friend to slowly fill water in the vessel. You will be able to see the coin once the level of water reaches a certain height. Why does this happen? The observed effects are created due to the change in the direction of light while coming out of water. Let us now proceed to the next part of the lesson, that is refraction of light. Light changes its direction when going from one transparent medium to another transparent medium. This is called refraction of light. Here in this diagram you will see the first refraction occurs when light ray enters the glass from air at point N on side PQ. The second refraction occurs when light enters air through glass at point M on the side SR. Laws of refraction. Incident ray and refracted ray at the point of incidence n are on the opposite sides of the normal to the surface of the slab at that point, that is CD, and the three, that is the incident ray, refracted ray and the normal, are in the same plane. For a given pair of media, over here you can see air and glass, the ratio of sin I to sin R is a constant. Here, I is the angle of incidence and R is the angle of refraction. Refractive index. We know that when light travels from one medium to another medium, it bends. But do we know how much light bends in different media? Now, the amount of bending when light travels from one media to another media can be measured by a physical quantity. This physical quantity of how much light bends when it travels from one medium to another is given by the refractive index of the medium. The change in the direction of light ray while entering different media is different. It is related to the refractive index of the media. The value of the refractive index is different for the different media and also for the light of different colors for the same media. Refractive index depends upon the velocity of light in the medium. Before we find out what is refractive index, let us recall something. We have learnt what is Snell's law. Snell's law states for a given pair of media, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. In other words, we say sin I upon sin R is equal to constant. This is known as Snell's law. Let the velocity of light in medium 1 be v1 and velocity of light in medium 2 be v2. Over here, medium 1 is air, medium 2 is glass. The refractive index of the second medium with respect to the first medium is equal to the ratio of velocity of light in medium 1 to that in medium 2. Refractive index of second medium with respect to first medium is equal to velocity of light in medium 1, that is v1, upon velocity of light in medium 2, that is v2. In the same way, the refractive index of medium 1 with respect to medium 2 is equal to v2 upon v1. Now, if the first medium is vacuum, then the refractive index of medium 2 is called absolute refractive index and it is written as n. The refractive index of a medium with respect to vacuum is called its absolute refractive index. When a light ray passes from rarer medium to denser medium, it bends towards the normal. You can see in the first diagram, the light passes from air to the glass. It bends towards the normal. In the second diagram, you can see the light passes from denser medium, that is glass, to a rarer medium, that is air. It bends away from the normal. When light ray is incident normally at the boundary between the two media, it does not change its direction and hence does not get refracted. Students, we are going to continue this lesson in the next video. Thank you for watching the video.